Today we're doing a full performance review of Intel's Beast Canyon NUC. We already did the teardown of this. There is some genuinely really cool mechanical engineering going inside of the small box, and we've confirmed that's Intel's mechanical engineering team behind it, not whomever is making the case. And that's always cool to see in the NUC because it's a really strong point of Intel's many development teams and product design teams that doesn't get as much attention because it's not a CPU. But that doesn't mean that the product itself is necessarily good value. And there are some problems with this film that we found along the way, like the guillotining cable, which is, by the way, something Intel told us they're working on, and also a really weird oscillating fan curve under specific conditions that Intel has accidentally configured. We'll talk about that too. Before that, this video is brought to you by Corsair and their 5000D airflow. The Corsair 5000D airflow is an ATX tower with high material build quality and a focus on cooling performance, with attention paid to small details. The case has a unique look with deeply indented cooling pathways on the sides of the front and top panels and has carefully matched colors across the case, available in both white and black. Learn more at the link in the description below. So the point of Intel's NUC series is to make mostly small computers. They've deviated from that in the past. The compute element was a little bit strange. Intel's had Phantom Canyon, Ghost Canyon, Hades Canyon, and a couple of others that we've looked at, but those are the three main ones we've reviewed anytime recently. And most of them are small to small adjacent. This is the largest we've looked at. This is bordering on basically a mini ITX computer. It's not very far from it, but it still has the same pros and cons that you would get from any custom, oddly sized computer, which is price. It starts at $1,150, goes up to about $1,400, and that's without a GPU, RAM, or an SSD. So you gotta buy your way up to actually have a functioning computer. And the other thing that comes with it is it's a little bit weird. So there's a compute element in here, which if you don't remember, is basically a PCIe socketable computer. It's an entire computer on a more or less video card, but it's not a video card. And that sockets into a PCIe slot. In this instance, it's socketing into a daughter board on the bottom of the NUC, which then has another PCIe slot that goes to the video card. So your CPU lanes come off the compute element, they go into the daughter board, come back up, and then you connect to the video card sort of in one slot down. Good mechanical engineering doesn't make the entire product though, when so much of it is also electrical. So you're relying on Intel CPU for the silicon. You buy the GPU silicon yourself, although there is an IGP. And then you're relying on the value overall of the total system after you buy the GPU, the RAM, and the SSD. And that's where the pricing gets thrown way out of whack with any other pre-built in the market if you're willing to have a true desktop, like mid-tower sized system, or if you're willing to build your own system, ITX, and get something roughly the same size as this and not too distant in price. But then you're eliminating the part where, well, you're basically building half of this too. So you're not too far away from it. Mechanically, we're not gonna go through all the mechanical details again. That's in the teardown. We'll link that below. But we wanted to point out that there's a lot of attention to detail that went into this design. It's missing in some places. For the most part, they've done a good job though. And we talked about that before, but the mesh paneling plus the negative pressure setup is what actually ends up working in a sort of brilliant way for the amount of space Intel had to work with. So Intel, this time different from last time we looked at a compute element system, shoved in basically a flow guide to pull air in from the outside of the chassis in through the back of the system, counterintuitively to what you typically see, and then guide that strictly into the compute element and nowhere else. And then it's using the top fans as exhaust, and since it's fully negative pressure at this point, other than your intake into the NUC, you end up pulling air in through every crack possible, and that means through the mesh panels, which directly benefits the GPU. There's some cooling downsides. They haven't done a great job with the SSD on the bottom of the system. We think that could be done much better. And additionally, it's still a little bit odd that the compute element isn't built backwards with the fan on this side, because then they could pull air in over here, and you've got two basically isolated systems, but they're not doing that, probably because they're trying to accommodate other types of builds with the compute element. So like Ghost Canyon that we looked at last year, Beast Canyon is based on the NUC compute element. These are fully functional computers. They're built into a card, and plugging a compute element into a normal motherboard doesn't really do anything exciting, but it shouldn't break anything either, at least not when we've tested it. Today, the system we're reviewing is the i9-11900KB kit system. It has an IGP, but no DGPU. The compute element has one HDMI port, two Thunderbolt 4 ports on board, that can make use of the IGP. And if another GPU is added, it goes into a PCIe 4.0 by 16 slot with support for coolers up to 12 inches long. That's the big change this time. They can fit full-length video cards. The rear of the case appears as though it would support 3 slot cards, but a 1 slot spacer is required for the CPU cooling duct, so compatibility is in fact limited to just 2 slots. This is unfortunately a pretty big limitation in the current generation, where a lot of the cards that are made are at least 2.5 slots. There are 2 slot cards, but as you get higher in tier, they're more difficult to find. The maximum estimated power allowance that Intel has stated is about 350 watts for the GPU alone. So that encompasses most of the non-partner high-end NVIDIA and AMD GPUs currently on the market, theoretically on the market, that is. 3 PCIe power connectors are provided, 1 8-pin and 2 6+2 pins. The power supply is standard form factor, but swapping it out isn't possible without modification thanks to the special extension cable running from the PSU to the socket at the rear of the case. As for the CPUs, this we need to clear up. The 11900KB, despite its name, is not in fact just a BGA version of the 11900K. So the 11900K is a socketed 14 nanometer plus Rocket Lake CPU with 16 megabytes of cache, UHD 750 graphics, that's 32 EU, 14 nanometer plus XE, while the 11900KB is a BGA 10 nanometer Tiger Lake CPU with 24 megabytes of cache and Intel UHD graphics for 11th gen Intel processors, as it's listed. To the best of our knowledge, that actually just means 32 EU 10 nanometer XE IGBs. The spec differences extend further too, but the bottom line is that they're different parts, except for having 8 cores and 16 threads. Enough of the physical hardware, let's get into the benchmarks and look at if there's actual value here. We'll start with some quick gaming benchmarks. These will hinge on the GPU and the RAM choices, obviously, but it'll allow us to evaluate the system from a value standpoint first. The value overall is bad. It's a small-ish box, but it's not that small, but it's very custom. And so the end result is expensive components that are relatively low volume compared to the rest of the market for ITX or something, and require other expensive components to use. We assumed MSRP for the GPU, so we're being generous, and for the other parts used, resulting in an assumed price of approximately $1,920 US as Intel shipped it in this configuration to us. In Rainbow Six Siege and tested in our pre-built testing suite, the Intel Beast Canyon NUC landed far below the $1,800 Alienware Aurora, which, by the way, you shouldn't buy, but that's a different story, with the R10 leading by 27% at a cheaper price. It's bigger, yes, and it has a lot of problems, but this helps illustrate that you're paying a lot for the size of the Intel NUC. Maybe that's okay with you, maybe it's not. That's really up to you to decide. For perspective, the ABS Challenger that has been actually pretty decent value previously achieves 75% of the performance of the Beast Canyon NUC in this configuration, while costing 52% of the price. The NUC performs fine, it's just the value is bad, even for a small-ish box, and it's not that small. It's not like the previous ones. At 1440p, the NUC holds 178 FPS average. Again, objectively good for this game, that's a good experience, but just 76% of the performance of a cheaper R10 or a similar configuration, and not necessarily justifiably ahead of the $1,000 pre-builts on the list. There are no illusions that, again, you're paying for the size and the case and the compute element, all of which are very custom. In Cyberpunk 2077, the Intel Beast Canyon NUC with the 3060, priced again at $1,900 or so, ran at 94 FPS average. This is meaningfully better than most of the others, but still only 82% of the performance of the cheaper R10. That's a full-size desktop, to be fair, but gives you an idea. And don't be tricked into thinking that you couldn't get equivalent performance as the R10 in a small-ish form factor. You could do it with a custom ITX build, but you might be in territory where it may not be available as a pre-built at this value. In Red Dead 2, the Beast Canyon build as it is attains 81% of the performance of the cheaper R10. The ABS Challenger achieves about 75% of the Beast Canyon's performance at, again, about half of the price. The perspective isn't really changing very much here. In Hitman 3, the system did comparatively better than previous relative results. It's now doing 90% of the R10's performance, which is thanks to its increased focus on memory performance and CPU performance, caused by our Hitman 3 settings is still behind, but the value improves and the benefits might start to outweigh the negatives here if you care enough about the other features offered by the Beast Canyon NUC. Frequency validation under a CPU and GPU strenuous workload immediately shows our turbo boosting duration limit getting hit. The CPU boosts to a maximum single core clock of about 4800 to 4900 MHz, but it only holds there for about 10 to 20 seconds. That's awfully short. There's an idle period before that at the start of the test, by the way, but usually we see a tau expiry closer to the range of 56 seconds. So after this period of 10 to 20 seconds, the clock falls to a maximum of only 3400 MHz. Thermals show us why that boosting period is so short. There's just no headroom for it. Despite all of the attention to detail and the design focus, and some excellent mechanical engineering overall on the NUC, the box still struggles to maintain reasonable thermals under a complete system workload. That's the nature of working with a box this size and working with functionally an entire computer inside of the form factor of a compute element. The CPU spikes to 90 degrees Celsius in our 21 or so degrees Celsius environment within just 10 seconds of the load starting. It then drops to about 75 C. This is why the boosting is so restricted. Intel can't support more performance than what's already coming out of the box for just those few seconds. GPU average core thermals ran around 70 degrees Celsius with the hotspot junction temperature at 80. That's for the card under test. The thermals on the GPU are actually pretty good. The AIB partner is largely responsible for this. However, Intel is still responsible for facilitating good cooling and access to air for the card. And the Beast Canyon box gives great access to air for the GPU, which is right against a mesh side panel and is afforded the benefits from a negative pressure setup right above it. That means that you're going to be pulling air in through every crack, and there's a lot of them in that mesh panel. A 3090 would struggle here for a number of reasons, but the main one is that the rear side memory modules would be right against the compute element. Looking at the fan behavior helps to show the rest of this. RPM on the CPU fan header ramps immediately to about 2400 RPM when the load starts. This makes for an aggressive, audible ramp and a little bit of a whine. The fan RPM dies back to 1800 RPM, and then it climbs to 2100 RPM over the next few minutes. This somewhat erratic behavior is more noticeable than just the noise level itself when it's louder. We think Intel could tune its fan hysteresis to ramp more predictably, and it's the sudden changes that are most noticeable to people. One problem we noticed was when the temperature was just a little bit higher. There's not much thermal headroom in this box before it starts acting all screwy, and that becomes evident in the fan oscillation that you'll see in this plot. With effective ambient temperature a little bit higher, the fan starts bouncing around like crazy because of how the fan curve is configured. It becomes increasingly audible as the fan wave wobbles, with wider amplitude each cycle. Depending on how warm your room is and how close the CPU runs to the limit of the curve, particularly in CPU plus GPU workloads, the fan can become noticeable in its speed changes. Before we show the noise levels associated with this, we can try and show why it happens. The default fan curve works as follows. The maximum CPU core temperature is below 54 degrees. The CPU fan turns off. If the temperature is between 55 and 67 degrees inclusive, the fan runs at 25% duty cycle. If the temperature is between 68 and 80 degrees inclusive, the fan runs at, prepare for this one, 2 times the parenthetically temperature minus 67 end parentheses plus 25% duty cycle. For example, if peak core temperature is 80 degrees, the CPU fan will be running at 51% speed. The system fans use a slightly different curve, but the 80 degrees Celsius maximum temperature threshold is the same. Above this max temperature, we've observed the fans going into Hail Mary mode, rapidly lowering the CPU temperature, which then causes the fans to drop the speed. Do you see the problem? Basically, as the fans ramp to try and compensate, they drop themselves back down below the level at which they started ramping, which creates this basically infinite cycle, and the CPU begins to overheat again. Sustained workloads in hot environments will trigger this oscillation. The easiest solution is to either select the cool fan preset in BIOS or manually raise the duty cycle increment to 5 or 6 so that the fan will approach maximum speed as the CPU approaches maximum temperature, rather than going instantly from 51% to 100%. To Intel's credit, all the values we've just mentioned are individually adjustable, something that we've praised before in previous NUC coverage. It's also worth remembering that all the NUC's BIOS settings are really just the compute element's BIOS settings. So the settings like fan curves have to cater to a wide variety of systems in which the compute element might be installed. For perspective on all this, we need noise. The standardized testing we do is 20 inches distance at the front of the box in a 26 dB noise floor, and we found the system idled at roughly the noise floor in our testing environment, with little noise coming from the NUC. You can see some occasional spikes as the fan tries to figure out what it wants to be when it grows up. It's trying to determine if it needs to be on or off. It then ramped to about 43 decibels under initial load, then fell back to about 35 decibels before climbing again to about 40 to 42 decibels. We'd like to see Intel flatten the fan curve on this to smooth out the noise to the end user, but overall they're not running in territory that we'd call objectively loud for the amount of power they're relying on for these smaller fans. You can also see the fans pulsing at the end of the workload. This indicates the actual problem of audible noise ramps and deramps every few seconds. Time to talk about setup, BIOS, and configuration. This is a kit PC, so there won't be any bloatware unless you install it yourself. For the most part, the BIOS is unremarkable. Enabling XMP is possible, but since the kits are sold without memory, that's up to the end user. Resizable bar is an option for the GPUs that support it. There aren't overclocking controls beyond the ability to make basic power limit adjustments, so users have to rely on XTU or other software for overclocking. To be clear, we'd strongly advise against overclocking on the i9 compute element at all, unless it's accompanied by a custom liquid cooling mod like the one we used previously. Going through CPU performance now, we tested a few of our standard CPU review applications like Blender and Code Compile to evaluate the CPU-only benchmarks, ignoring the modular GPU. Blender has the 11900KB at 22.6 minutes time required to complete the render. That has the 11900K non-B desktop CPU leading at 18 minutes, or about 20% reduced time. The 11900KB is closer to the 9900K in performance, thanks to its frequency limitations almost entirely. And again, just a reminder that the GPU, although it's listed, doesn't actually matter here because it's not doing anything. The 5600X is about the same as the 11900KB, regardless of its core deficit. In Chromium Code Compile, the 11900KB again aligns closer to the AMD R5 5600X or the Intel 9900K, more so than anything else. The 11900K at full frequency required 97 minutes to complete, or a 26% reduction from the 11900KB. Finally, as for physical hardware, we're not going to go through this in too much detail here because it's all in our teardown. We really spent a lot of time explaining it and exploring the hardware. But a couple of things. The power supply is modular. It's a small form factor 650 watt 80 plus gold FSP unit that may be an off-the-shelf part based on the model number, but it does not have a separable power or a normal power cable. There are unused modular connections on the power supply. The heat shrink on ours was not properly applied. It was loose, and so there was exposed, not wire, but exposed wire shielding under the outside rubber housing. And anyway, the unused modular connections are a clear indication that this isn't only a NUC product, but maybe it's been slightly modified. This is somewhat unusual because Intel has championed its ATX 12 volt only, or 12VO standard for pre-builds, and has created a pre-built that only really needs 12 volts power. But they still opted for a normal power supply with 5 volts and 3.3 volt capability. The NUC has an impressive complement of 4 M.2 slots, 3 contained within the body of the compute element and 1 on the daughter board underneath. One slot is M.2 2280 PCIe by 4, that's CPU lanes, that's Gen 4 NVMe. 2 slots are M.2 2242 or 80 PCIe by 4 PCH lanes, those are Gen 3 NVMe or SATA 3. And the final slot on the daughter board is M.2 2242 or 80 or 110, and it's PCIe by 4 CPU lanes Gen 4. The daughter board M.2 slot is by far the easiest to access through a special hatch on the bottom of the case with what is supposed to be an integrated heatsink, but it's basically just stamped steel, which is not a good conductor, sunken into plastic, which is an insulator, so it could be done better. The 2 side-by-side PCH attached slots inside the compute element are RAID 0 and RAID 1 capable. So that's it for the Beast Canyon NUC. This thing, if we assume MSRP for the components that you have to buy to install in the kit to complete the computer, is expensive. It's not really, it's completely unjustifiable compared to a similarly or equally priced computer if you're willing to go with a mid-tower. The place where it doesn't matter what a mid-tower costs is if a mid-tower is too big. And at that point, you should probably be building your own ITX computer because it's still going to be cheaper than this. It will maybe not be quite as small, but you'll be pretty close. And given the price performance difference, it's worth it, we think. If you can't, don't want to, or for some reason are not able, not willing to build your own computer, whatever the case may be, that's totally fine. That's completely valid, and that's what pre-builts exist for, is exactly that use case. However, it's worth shopping around at other pre-built SIs, system integrators, who might make ITX systems, because it's possible you'll get a better deal. What this does is make an incredibly specific, somewhat unique, by comparison of volume to others in the market, relatively small box that fits a full-length video card that has thermal problems, and which is moderately expensive. So there's some pros and some cons in there. Intel, once again, has done, overall, we would say, a great job mechanically engineering the enclosure, the assembly of everything. Even the disassembly isn't too bad. It was a little confusing the first time to take the whole thing apart, but it's not that bad. So mechanically, Intel has done phenomenally here, with a few exceptions, like the guillotining cable, the wireless antenna cable got sliced. And again, to be clear, to point this out, that was like that when we first opened the box. So when Patrick first opened it, before I ever looked at it for the teardown, we noticed it was sliced, and that aligned with some connectivity issues that we had previously, so everything made sense suddenly. Of course, you should not be buying a product just because the mechanical engineering is cool if nothing else makes sense. So this NUC, out of all the ones we've looked at, is one of the hardest to defend on value. The thermals need work. The CPU is only able to boost for 10 or 20 seconds under a full system load before it has to back off hard and lock itself to about 3400 megahertz within 20 seconds of load. That's not good. And that's why you get 9900K performance in things like Blender, which are sustained workloads that are constantly on the CPU. Because they're dialing back the frequency so much, because of the power limitations, and all of that is because of thermal. And then noise is also poorly executed. Intel's really messed it up here. They completely stuffed up their execution on the hysteresis. The fan curve needs work. We went through the formula for the fan curve. It shouldn't be that complicated until you don't need formulas to do fan curves like this. Where it basically, to recap, goes into freak out mode and blasts the fans, gets past the threshold by about 1 degree Celsius on the CPU, and then kills the fan speed back down to like 50% or something. There are ways around this. We've explained them, but this needs to be done better, Intel. It's the oscillating RPM is noticeable to an end user. And in fact, it's noticeable on the previous ones as well, but more so on this. So anyway, that's it for the NUC review. We can't really firmly recommend buying this. It's mostly fine. Some of the engineering is very good. You will need to help it along with some of the other stuff that, like thermals, making sure it's in a good environment, maintaining it well. Don't let too much dust build up on there. And probably be careful about putting a 3090 in there or something. That might be a bit much. So that is a bit much. So as long as you keep those things in mind, we don't hate it. But it's just the value isn't there for us to give it a firm recommendation versus DIY or buy from some SI. So you're paying for something unique, basically. Not always a great thing to pay for. That's it for this one. Thanks for watching. Subscribe for more as always. You can go to store.gamersnexus.net if you'd like to help us out directly, or grab something like one of our mod mats, which are what we did the teardown on. Those will be back in stock soon. So if you want to get one, you can back order to guarantee you get one in the next run. They always sell through very fast. And you can go to patreon.com/gamersnexus. Thanks for watching. We'll see you all next time.